So, in the past few lectures, we have discussed about the introduction of the electromagnetic theory, the necessity for studying the electromagnetic theory, and the basic principle regarding it. And then we have discussed the potential formulation, then we have discussed the conservation laws, then we have discussed the electromagnetic wave in unbound medium. So, while discussing the electromagnetic wave in unbound medium, we have discussed first the electromagnetic wave in vacuum. Okay. So, after studying the electromagnetic wave in case of vacuum, we have turned to the case that the electromagnetic wave in linear isotropic dielectric medium. What is the form of the electromagnetic wave in this case have been studied already. Okay. And what is the relationship between the electric field and the magnetic field in case of the electromagnetic wave in linear isotropic dielectric medium have been discussed very simply. Okay. So, in this case the refractive index has been determined, and also the transverse nature of the electromagnetic wave is shown, and also we have noticed the interesting fact that E and H are in same phase. This is very crucial. Okay, the electric field and the magnetic field are in phase in case of electromagnetic wave in isotropic linear dielectric material. This is also true in case of the vacuum that we have already studied. If you want to see, then okay. Mm, 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 mm. From these you can conclude that the propagation vector is not at all a complex number, is purely real number. So there is no any phase difference lying between the electric field and the magnetic field. Okay, this, and the transverse nature can be proved easily by the Maxwell's equation, which shows that k dot E is equal 0, from which equation 1 or 2. Okay, equation 1. And from equation 2 you can also conclude that k is perpendicular to B also. This, okay, and there is no phase difference present between the electric field and magnetic field. This is shown by the beautiful graph. Now we are interested to discuss the electromagnetic wave propagation through conducting medium. Also, the interesting point to see in case of in linear isotropic dielectric medium, that in the linear dielectric medium the electromagnetic energy is equally shared between the electric and magnetic field. This is a very important conclusion, the conclusion number 4. Okay, now we will see the case for the conducting medium, and in case of the conducting medium we can also conclude some another feature that are different from these conclusion. Now without wasting any time, I must proceed to the next section of our discussion of electromagnetic wave through unbound medium. Okay, let me check. Okay, my voice is clear. Okay, so let's start our discussion. Okay, electromagnetic wave in conducting medium. Conducting medium. You have been already habituated by the formulation that I am proceeding while discussing the electromagnetic wave in different medium. What is the general procedure? At first we have to write the Maxwell's equation regarding the different conducting medium. Regarding different medium, at first we have discussed the form of Maxwell's equation for the case of vacuum, Okay. Next, we have discussed the form of Maxwell's equation in case of linear isotropic dielectric medium. So here also we have to discuss the Maxwell's equation in conducting medium. So what is the form of Maxwell's equation in conducting medium? Let us discuss first. Okay. So Maxwell's equation. The method is general. Okay. Every time you are going to study the electromagnetic wave propagation in different medium, you have to write at first the Maxwell's equation in the given medium. Then you have to operate some mathematical operations on it and evaluated some beautiful conclusions that I am going to show you. Okay. So Maxwell's equation in linear homogeneous isotropic conducting medium. What terms I have introduced here? Conducting medium, sorry, conducting medium. What terms I have introduced here? Let me discuss. Linear. Why it is linear? Because the conductivity and the permittivity is scalar quantity. So it is linear. That is rank 1 tensor. Okay. Why it is homogeneous? Because the uh, density of the medium is same everywhere inside the medium. The density at this point is also same the density at this point also, and it is also same at the density at this point also in the given medium. Okay, so in every point the density of the medium is same, so the term homogeneous have been introduced here. Now why the term isotropic has been introduced here? Because isotropy means if you want to measure some quantity along a particular direction, then this will be similar to the property measured by any other direction. Whatever direction you follow, the same physical quantity you are end with. Okay, you have end with the same physical quantity. The physical quantity will be same in this direction also, the physical quantity will same this direction also, the physical quantity will same this direction also, and it is same for this direction also. So the term isotropic have been introduced here, and our main purpose is to solve the Maxwell's equation in conducting medium. So we have obviously we have to consider the conducting medium. Okay, so the explanation regarding this term have been discussed. Now let's proceed for that. Sorry. Okay, so let me write. What is the first Maxwell's equation? Del dot E is equal 0. Why 0? I consider here that there is no charge density present inside the dielectric medium, sorry, inside the conducting medium, as because all the charges are present at the surface of the conducting medium, not inside. So the inside the conducting material the charge density is 0 always, as because we know that in a charged conductor the charge resides only at the surface, not on the inner portion. So at the inner portion the charge density is 0, so that del dot E is equal 0. Okay, now the second term is del dot B is equal 0. The magnetic monopole does not exist, which implies del dot H is equal 0. The divergence of magnetic intensity is also 0. Okay, so this is the number 2 Maxwell's equation. Number 3 Maxwell's equation is what? The curl of the electric field. Curl of electric field is equal to minus del V del T. which is the differential form of Faraday's law. Now again we know that for a magnetic sample, the magnetic induction vector is equal to some mu into H, where mu is the permeability or magnetic permeability of the given medium, of the given medium. Okay. Similarly, we can also write that electric displacement vector is equal to some epsilon into E, where epsilon is called the electric permittivity by permittivity electrical permittivity sorry electrical permittivity of the given medium. Okay, so these are the two relationship between the magnetic induction vector and magnetic intensity and electric displacement vector to electric field. So from this we can easily conclude that this is nothing but equal to some minus of mu into del H del T. You have to remember only one form of the Maxwell's set of equation. Then you can modify for different medium. Okay. So I have been memorized only the del dot E is equal rho by epsilon naught. Here rho is 0, so this is 0. Del dot B is equal 0. Del cross E is equal minus del B del T. And for this case, we can modify this by minus of mu into del H del T. If the space was free space, or if we have to study the electromagnetic wave in free space, then the mu should be replaced by mu naught. That I have already discussed in the past few lectures. Okay. So you have to memorize only one set of Maxwell's equation, then you can modify this on your requirement. Okay. Now del cross B, or more generally we can define del cross H. Uh, let me write the original form so that the okay, del cross B is equal mu naught J plus mu naught epsilon naught some daily del T, which is for free space. Okay, mu naught epsilon naught. Okay, let me generalize this by avoiding the naught term. Okay, so this is the more general formula. So if we divide the B by mu, then this mu and this mu will get cancelled out and we get this as H. So we can write this as J plus epsilon del E del T. Now for the conducting medium, we can say that J is related to conductivity and the external electric field. From which relation this is true? From the differential form of Ohm's law, sorry, the vector form of Ohm's law. Okay, so from this you can easily conclude that equation 4 should be modified by del cross H is equal mu E plus epsilon del E del T. What is the epsilon? Permittivity, electrical permittivity of the given medium. Okay. Okay. Have you any doubt regarding this set of Maxwell's equation? I think you should not have any doubt, as because these are the previous discussion. Okay, just some modification have been done here, and you have already habituated by the formation which is going to follow. Now, let me proceed further. We have to take the curl on both sides of equation 3 and equation 4, and let's check it what gives this result. So del cross E means minus mu, as because the space and time part are independent to each other, we can interchange the order of differentiation with respect to the space and time part. Okay, so we can differentiate the H at first by the space part with respect to space part, and then with respect to time part. Okay, so from equation 3 this have been done. What is the vector identity here? Del cross E plus del of del dot E is equal sum minus mu del t of, what is the meaning of del cross H? Okay, this del cross H means this. So put the value this and this. Okay. Now what is the value of this term? Have been already discussed. Okay. So this is going to be 0, a big 0. So minus del cross E, sorry, del square E means minus of mu sigma del E del T. Let's avoid the negative sign, okay? This is going to a big 0. So let's avoid the negative sign, as because negative sign cancels out each other. So this del 2E del T2. Now by changing the side you can modify it by uh, del square E minus mu sigma, okay, del E del T minus mu sigma, sorry, mu epsilon del 2E del T2 is equal 0. Put it in a box. We have to solve this equation. So name it as equation number 4. I think this should be named by equation number 5. Now let's proceed further for the case of 4. From 4 we can also take curl on both sides, curl of H, which means the curl of, okay, sigma into curl of E, okay, plus epsilon del T of curl of E. Now this can be written from vector identity curl square H plus del of del dot H is equal, what does the curl of E implies? Curl of E implies minus mu del H del T, minus mu sigma del H del T, and this is also minus mu epsilon del 2H del T2. Again this is going to be 0 because of del dot H, and all the negative sign will get positive. So if we interchange the position, we can able to obtain the equation as grad squared H minus mu sigma del H del T minus mu epsilon del 2H del T2 is equal 0. Put it also in a box and named it as equation 6. So these are the equation obtained by the mathematical modification of the Maxwell's set of equation. Now we have to solve these two sets of differential equation by our known method of complementary function, as because there is no any particular integral present on the right hand side. Okay, so if you are going to solve this by the differential equation method, then you will also able to obtain the solution as plane wave. If you take the plane wave solution, then you can also able to obtain E as equal to some E. Okay, let me write it in a more general way. Electric field as a function of position and time is equal to some E naught, which may be complex amplitude. Okay, E naught is the complex amplitude of the electric field into exponential of I of k dot r minus omega t. If we take the plane wave solution, then we will able to obtain the form of the solution of electric field as this. Similarly, we can also write the magnetic field also r comma t is h naught exponential of I k dot r minus omega t. Okay, these are the sets of solution. You can also take the spherical wave solution. We will discuss this in later lecture. Let me first discuss it by plane wave solution. So by the considering plane wave solution, you will also able to obtain the electric field and magnetic field as this form, where H naught and E naught are the complex amplitude of electric and magnetic field. Now by substituting these 7 sets of solution in 5 and 6, you will also able to obtain. Okay, let me first put the first part of 7, that is E, in 5 by putting the value del square E. If you take the divergence of this electric field, then you will also able to obtain I k dot E. This will take out from this and this will remain. So if you will be able to obtain this. Now if we take again the divergence of this, then this becomes some minus k square of E. Okay, so I am going to some step jump because uh, if I will not go, then the lecture will be too long. Okay, so you have the homework as to discuss it by elaborately or by done it by elaborate method. But because of this short time, I must have to step jump here. But the reason behind it is discussed here. If you take the single divergence of E, you will get ik dot E, and if you take again the divergence of this, then it will result also minus ik dot E, and E dot E becomes E square. Sorry, the E will be take common, and ik means minus k square. Okay, okay. Now similar operation, if you are going with H, then you will also get uh, the first term of this equation as minus k square H. Okay, so again if you take the del t of E, then minus I omega will be take out from the exponential expression and all the term remain the same. So if the all the term remain the same, that is E naught exponential of this totally means E vector na. Okay, and if you take the del t, then I omega simply comes out, and this I omega have the negative sign in front of its expression. So this negative and this negative becomes positive, and we will get minus k square. So from this, by substituting the first set of equation 7, we will also obtain k square E plus mu sigma will remain as it is, and I omega. So I omega. Okay, now if you take again the del t of this, then you will also able to obtain another I omega, which means I minus 1, and this minus will be plus, so this will be minus and minus plus omega squared, omega into omega squared into mu epsilon into E. E. So by satisfying the equation number 5 from the first set of equation 7, we here obtain the equation to be replaced by the solution and take the form of this. Now on further simplification, we can get minus k square plus mu sigma I omega Okay, so mu sigma I omega plus omega square mu epsilon E vector is 0. Now for non-zero solution, E not equal to 0. So this term should be 0, that is minus k square plus mu sigma I omega plus omega square mu epsilon is equal to 0. From this we can also obtain k square equal to be omega square epsilon mu plus I sigma omega mu. This is very much interesting. This is very much interesting and somehow different as obtained by our previous cases. Why? Because here the k terms involve some imaginary part also along with the real part. What would affect the solution will be discussed. Okay, so here you have to carefully notice that an imaginary term is also present along with the real term in the value of k square. So k square is nothing but mu mu epsilon omega square plus I sigma omega mu. So we can conclude that k is complex in character. This is the conclusion number 1. Conclusion 1. Okay. Okay. This is the conclusion 1. Now let by taking each also we can able to obtain this result, but I am going with electric field as because you know that electric field is more crucial than the magnetic field in discussing the electromagnetic wave. Why? The light wave may be taken to be as the electric vector because all the photographic plate and the experiment involves the electric field vector. Also the vision, sensation of vision is also responsible for the electric field only. So light vector is also composed, sorry, the light vector can be said to be electric vector or can be taken to be electric vector as because the major contribution of electric field to the light. Okay, so I have taken the solution of electric field for discussing the conclusion obtained from the dielectric, sorry, from the conducting medium. If you able to you can also able to obtain the conclusion by applying the magnetic field also, but the discussion for electric field is more crucial and important. So let us proceed further. If we take k as alpha plus I beta, then you can also obtain k square to be alpha square plus beta square plus 2I alpha beta. Here a minus term will be present here. Why? I am basically taking the whole square term. Okay, so there will be negative sign here. Okay, so this first bracket, first parenthesis involves the real part and the second parenthesis involves the imaginary part. So by comparing this with this term, we can also compare the omega square epsilon mu to be alpha square minus beta square. Let us write this is nothing but omega square mu epsilon, and 2 alpha beta is nothing but sigma omega mu. I have compared the left hand side equations and the right hand side equation as because all these are involves k square only. So I am writing these just by comparing the k square, the real term and the imaginary term present in k square. This involves not too much difficulty. Okay, so you have to solve these two equations to find the value of alpha and beta. So let us go into the deep solution regarding this, which is a very much lengthy. So I'm going to the solution in detail. So we have obtained that alpha square minus beta square is nothing but omega square mu epsilon, and we also obtained that 2 alpha beta is equal sigma omega mu. So from here we can also write beta is equal omega sigma mu divided by 2 alpha. So by substituting this beta in this equation, you will also able to obtain alpha square minus omega square sigma square mu square by 4 alpha square, okay, is equal omega square mu epsilon. Okay, so from this you will get alpha square whole square minus, if you take LCM as 4 alpha square, then this will be this and this will be okay, this. So this is the epsilon term involves. Okay, now side change, if we take this term on the left hand side, alpha square term involves here, so 4 omega square mu epsilon alpha square minus omega square sigma square mu square is equal to 0. From this we can easily obtain alpha square by the Sridhar Acharya formula. Okay, minus b, that is minus minus plus 4 omega square epsilon mu minus b plus minus root over b square, means 16 omega to the power 4 epsilon square mu square minus b plus minus root over b square minus 4ac minus minus plus 4, a means 4, so 4 into 4 means 16. Okay, and c means omega square sigma square mu square minus b plus minus root over b square minus 4ac divided by 2a. 2a means 2 into 4 means 8. Okay, now take 4 from this. If you take 4, then this will be this will not present here, so 4 4 and this cancels out, and we will obtain alpha square as omega square. Okay, take half at uh, outside the bracket, so omega square mu epsilon plus minus 2, and this take omega square epsilon mu as common outside the square root, so this we can take common of this term, and in the parenthesis, sorry, in the square root we can able to obtain sigma by omega epsilon whole square. Okay, so now let us take common of this and this term, so alpha square will be equal to nothing but half of omega square mu epsilon 1 plus minus under square root, here plus signs, sorry, plus sigma by omega epsilon whole square. Yes, now we have obtained alpha square. From this we can also obtain alpha is equal omega square. If we take square root, then only omega will be outside from the square bracket, sorry, square root term. So in the square root, mu epsilon by 2 will be present, and these alpha plus minus. Okay, let us first write the second term in the first position, 1 plus sigma by omega epsilon whole square and plus 1. Okay, plus 1 and also we have to obtain the plus minus. If you take the square root of this term, then this will result plus minus of root over of this term. Okay, root over of this third bracket term. So by considering the plus minus sign, we can take this alpha is equal this, and the another solution will be all these terms will remain same, but there will be negative of minus 1 under square root. What is this? This is nothing but beta, as because there are two roots of the quadratic equation. These are alpha and beta. So we were going to evaluate alpha and beta, and we here able to obtain the solution of alpha and beta in terms of omega, epsilon, sigma, etc. Okay, so I have write that k can be expressed as alpha plus I beta. So ik will be expressed as I alpha minus beta. Now the solution of electric field that already discussed is nothing but function of both position and time, E naught e to the power I k dot r minus omega t, and each will be r t h naught I k dot r minus omega t. Okay, so by putting the value of k, sorry, ik will be more general, ik, you will able to obtain in terms of alpha beta e t by writing only one. The similarly we can write the magnetic field. Okay, so E naught e to the power I k dot r. I k means alpha, so here does not, beta term does not connected with I, so we can take this as common, minus beta. Again, if we take the propagation vector is along the n cap direction, n cap unit vector direction, then this will be represented by n cap dot r dot r k n cap dot r. K dot r means k n cap dot r. By replacing k, sorry, more general ik, then we will able to obtain this term. Next we have to write the exponential item alpha of n cap dot r, sorry, uh, n cap dot r r minus omega t. Similarly you can write this also. Okay, these are modified solution 7 and named it as 11. This is uh, okay, this is the 6, this is the 7 number term, 7 number equation. mm, 8, 9, 10, and this is 11. Okay, so the 7 number equation gets modified due to the conducting medium by 11 number equation. This 7 number equation, this 7 set of equation gets modified by the 11 sets of equation for the linear isotropic conducting medium. Okay, this term involves exponential minus beta. N cap dot r gives some scalar value. Okay, so this term involves the special characteristic. What does it imply? It implies some exponential decay of some of some quantity. As because it is related with the electric field, it will imply the exponential decay of electric field amplitude. And similarly for magnetic field also, we can define that the magnetic field is also attenuated or decay on passing through the conducting medium due to the presence of these exponential terms. So what we can conclude? We can conclude, sorry, we can conclude, this is the conclusion number 2. Conclusion number 2, we can conclude that the field amplitudes are spatially attenuated, not temporary, because it involves only n cap dot r. So spatially attenuated, and the attenuation due to, why there is attenuation? Due to the Joule effect or Joule loss. Okay, why Joule loss? Because the conducting material involves some current flowing at the surface. So while passing the electric field, some Joule loss occur at the surface of the conducting medium, and while passing through the surface, the wave will get dissipated like this way. Okay, the electromagnetic wave will get dissipated while passing through the conducting medium. Okay, okay, the quantity beta is called the measure of attenuation. Okay, attenuation measure, because this term also, only gives the factor of attenuation on which it attenuated. So attenuation measure of attenuation. Okay, and for a non-conducting material, the beta term will get simply vanished, as we have obtained already while discussing the dielectric medium and free space medium, in which the electric field will no further dissipated. Okay, but in the presence of conducting material, due to the presence of sigma term, the beta factor is present. So due to the presence of the beta factor, the electric field and magnetic field is also dissipated while passing through the conducting medium. So for non-conducting medium, beta is 0. Why? Because sigma is 0. Because sigma is 0. So if you place the value of sigma 0, then 1 minus 1 will get 0 and beta will no longer present in the term, and the equation will get transformed into the previous state of matter. Okay, now the quantity 1 by beta gives some useful quantity. What is it implies? It implies the factor or the distance up to which it can flow inside the material. Okay, the amplitude of the previous electric field gets 1 by e times, exactly 1 by e times of its initial amplitude, the distance up to which it is called skin depth. Okay, let me define skin depth physically. Skin depth means the distance up to which the electric field or magnetic field amplitude gets 1 by e times of its initial value, initial value, initial value. Okay, so this is called the skin depth. Skin depth gives the factor up to which the electromagnetic wave can flow inside the conducting medium. Okay, now for a good conductor, for a good conductor, for a good conductor, sigma is very high. So sigma by omega epsilon much greater than 1. Okay, so if this term much greater than 1, then this will simply involve the square root of sigma by omega epsilon whole square, and will give only sigma by omega epsilon minus 1 whole to the power half. Again this term is very high compared to 1, so this will imply nothing but sigma by omega epsilon, and this term is present outside the parenthesis, so omega into mu epsilon by 2. So epsilon will get cancelled out, omega will be root omega, and there will be present some mu omega sigma divided by 2. This will be beta. If you apply the same condition in case of alpha, then you will also get that alpha will also equal to root over of mu sigma epsilon divided by 2. So for good conductor we can conclude alpha is equal beta nearly about root over mu sigma omega divided by 2. If beta we this term, then delta or skin depth will be 1 by beta, that is 2 by sigma mu omega. Put it in the okay box. Okay, what conclusion can be drawn from here? Conclusion number 3: if the the frequency of electric and magnetic field as well as the conductivity increases, the skin depth will get decreased. That is, the wave will get dissipated faster. Okay, at a faster rate. But if omega or sigma decreases, delta will increase from this relation. That is, the skin depth will get high. Okay. Okay. Now let us prove our previous properties that we have already encountered in case of dielectric and free space medium. What conclusion from these conclusion are drawn from the 3 and 4. Now we are going to apply 1 and 2 condition. By applying 1 and 2 condition, you can get uh, del dot E is equal 0, means ik dot E is equal 0 from the plane wave solution. So we can generally say k dot E 0. What does it imply? It implies that k is perpendicular to E, which again proves that electromagnetic wave is transverse in nature. Again from del dot H is equal 0, we can also obtain k is perpendicular to H also. Okay, so we can say that E and H are normal to the direction of propagation, means electromagnetic wave is transverse in nature. Okay, again from the third condition k, what is the third condition? I think curl of H, sorry, I think curl of E, yes, curl of E is equal minus mu del H del T. So taking curl of E from the plane wave solution, we also obtain Ik cross E, Ik cross E. Okay, let me at first uh, again verify the results obtained from here. What results are obtained here? That the electric field and magnetic field is dissipated or attenuated. Why? This is similar to what kind of motion? Damping motion. Okay, this is similar to the damping motion. If you carefully observe the equation obtained at 5 and 6, then you can also notice that these equations are nothing but the differential equation for damped motion. If you have forgotten it, then let me uh, remember you. Just a second. Okay. Yes, this is nothing but the differential equation for the damp motion. Carefully observe d2x dt2m plus k dx dt plus sx equal to 0. This is the differential form of damped motion, which is nothing but obtained here also. d2x dt2 m d2x dt2, here the same form is obtained here. So these are nothing but the damping equation. So the solution is quite significant here, which gives the damping property by the exponential minus beta term. Okay, now let me write, okay, let me copy the set of Maxwell's equation, as because it will be very helpful. Okay, so from 3 you can conclude that Ik cross E is equal minus mu del H del T, that is uh, minus mu del H del T means minus I omega, del T means this, so this is H. Okay, minus minus become plus I omega mu H. So by cancelling I on both sides, so we can obtain K cross E omega mu H. Okay, put this at equation number 13. This is 2. So put it in a box again by applying 4 equation. uh, I k cross H equal to J means sigma E and plus epsilon into del T means minus I omega to E, so sigma minus epsilon I omega into E. If you take negative as common and divide I by both sides, then you can get K cross H means I gets cancelled out and minus term will be again here and minus epsilon omega. This will be minus and take minus common, so this will be minus of minus I sigma. This means I square, minus of I square. So by cancelling this, the minus I and minus of I square into sigma. Okay, so by cancelling I we get minus I sigma and uh, take minus 1 common and minus 1, so this, okay, this term will be plus. Okay, these are the results. After simplification you will able to obtain k cross h equal to minus of omega epsilon minus I sigma into E. So from this you can say that uh, H is also perpendicular to both K and E, and here you can also conclude that E is also normal to both K and H, okay, or perpendicular to the direction of propagation and magnetic field. So you can write this also, but I am not writing this because I have written it already many times. Okay, now from the 13 equation, if you take the magnitude, then you can also check that K is perpendicular to E. I have already shown it. So K cross E means Ke sin 90 means 1. Okay, and this is the Ke only magnitude. We take only magnitude. So omega mu magnitude of H. Okay. Okay. Or okay. Let me write it in more general form. So take the magnitude of H at first. This is nothing but 1 by omega mu, and the cross product of this means K means alpha plus I beta into some n cap, as because K is equal K in cap. I have already shown it in the upper slide. So alpha plus I beta n cap cross E. Okay, this. Okay, so 1 by omega mu and any complex number z equal to alpha plus I beta. So you can also uh, express these as exponential I theta, where theta is tan inverse beta by alpha. From the complex analysis you already know this. So we can also take this as root over of alpha square plus beta square, which is the modulus of z, that is the modulus of k, okay, into some e to the power I tan inverse beta by alpha. So this term get completed into n cap cross E. Okay, what does it imply? It implies a beautiful conclusion. What does it imply? Conclusion: the magnetic field and the electric field are no longer in phase, are no longer in phase. Okay, this is the beautiful conclusion. In the previous cases we have obtained that the electric field and magnetic field are in phase. Let me show you. Yes, electric field and magnetic field are in phase in the previous cases, but in our present discussion we have obtained that electric field and magnetic field are no longer in phase, but the magnetic field lags behind the electric field, the electric field. Okay, so if I'm going to show you by graphical method, then let me show you by graphical method. This. Okay, so let me first draw the electric field. We take the plane wave solution, so the electric field will be like this, but it is attenuated, so the amplitude will get decreased by the way of propagation, like this manner. Okay, this. And also the magnetic field can be expressed as this, but it also dissipated and not in phase, so this will be like, sorry, this will be like this, and like this, not at all in phase. Simply I want to demonstrate that the electric field and magnetic field are not at all in phase, that I have obtained it in mathematically. There exists some relative phase difference between the electric field as well as the magnetic field. So this is the magnetic field and the electric field is this. Electric field is this. Electric field is like this. Electric field is like this. Electric field is like, electric field is like this. Okay, so the pink light is this, sorry, pink indicates this, and the wave is also attenuated, which can be shown by this dotted line, and the magnetic field is expressed by blue, which is also attenuated, which can be shown by this dotted line. Okay, this way. So the electric field and the magnetic field, okay, let me denote these as, let me denote these as y-axis, let me denote this as z-axis, and let me denote this as x-axis. I just want to show you by graphical method how the electric field and magnetic field transverses. Okay, and these nomenclature xyz and taken arbitrarily, but mathematically you can also determine the direction in which the electric field magnetic field uh, flows in the medium, but I here choose the arbitrary xyz coordinate system. Okay, here my motive is just to show you or demonstrate you the change in electric field and magnetic field from the dielectric medium case or the free space case, that in the conductant medium. Okay, so the relative phase difference is determined by the term tan inverse beta by A. Okay, so by tan inverse beta by A, you can also able to obtain the relative phase difference between these. Now, for a good conductor, alpha equal to beta equal to mu omega sigma by 2 under root of, we have already showed this, that this, So for this case, alpha equal to beta for good conductor. So for good conductor, for good conductor, alpha equal to beta, and the phase difference will be tan inverse beta by E alpha, tan inverse 1 pi by 4 or 45 degree. Okay. So these are all about the conducting medium case, electromagnetic wave in conducting medium, which is somehow interesting and rather different from that obtained from dielectric medium and free space medium. Okay, thanks for watching. If you like, then you can subscribe this channel for more update. Thank you very much.